we're Team Jayco Embedded Solutions, and today we'll be presenting our Range Recon drone project. I'm Cody. I'm a third-year computer science major, and I'm primarily responsible for the firmware development.
My name is Jeremy. I'm a fourth-year electrical engineering major, and I was primarily responsible for hardware development and firmware development as well.
So going into this class, we both knew that we wanted to gain some experience designing and implementing an embedded systems project from scratch, and we also knew that we wanted to develop a project related to aerospace. So that was where we first came up with this idea of creating an aerial photography drone that would allow you to get a better vantage point if maybe you're stuck in a busy parking lot or if you're in a large open space like a park. So to do that, our plan was to first develop the low-level sensor drivers that would be necessary for flight control, then develop sensor fusion and flight control algorithms on top of that, allowing us to first get the drone off the ground. And then finally, we would design and assemble a custom flight controller PCB that would allow us to consolidate the hardware design and improve our flight performance.
Here is a picture of the first drone prototype that we assembled for our project. This drone featured our earliest edition of our hardware drivers, particularly for controlling our motors, for our inertial measurement unit, as well as for our RF transceiver module. Given that these drivers were in their early stage of development, there was still a lot of bugs within them that served as a foundation to some of the even bigger problems that we face with this prototype, such as having a very early stage sensor fusion algorithm and flight control algorithm. Here's some videos that we took early on that showcase the performance of the V1 prototype.
Recording.
Ready?
Yep.
Oh!
All right, going. Okay, turn it off.
Bro, I didn't.
So eventually, after enough crashes of our first prototype, we were forced to move on to the V2. In this version, we updated our transceiver driver to eliminate garbage values from RF. We implemented barometer and camera drivers to get initial altitude and picture readings. We improved our IMU drivers by tuning the sensor a little bit to make it more accurate and stable. And we also implemented our first version of the Kalman filter, which allowed us to create a basic flight control algorithm.
Oh my god. Oh, okay, alright. Better land this safely. Oh. Okay. Oh.
After getting some successful flight results with the V2, it was time to move on to the V3. The problem with the V1 and V2 prototypes, even though we were able to get our flight controller algorithm working, was simply that they lacked enough space to store all the components that we needed for our drone. More specifically, the V2 didn't have enough space to support our camera and SD card modules, which were big pieces that we needed to incorporate into the drone moving forward. The new V3 definitely has enough real estate for us to store all of our components that we'll need for our drone. And another added bonus with this V3 prototype was that the center of mass is a lot more center compared to the previous modules, meaning that our flight control algorithm has to work a lot less to balance the craft. Another important aspect of our project that we would like to discuss is the development of our Range Recon Mark I flight controller, shown on the right. The goal with developing our own PCB is to develop an integrated solution that houses all of our sensors and microprocessor on the same board. This is going to make it easier for us to test and troubleshoot, since we don't have to worry about jumper wires getting unplugged, among many other things. The development of our own PCB also provides us a baseline to improve on future designs. Say if we want to add different connectors, different sensors, we can just update our PCB design and prototype from there.
So as for our next steps, now that we have the first version of our PCB physically, we would like to assemble the custom hardware to consolidate our drone design in a version 4. We would like to further optimize our flight control algorithm to allow us to reach greater heights. We would like to implement altitude control to allow the drone to be more stable when it's at those high altitudes. And finally, we would like to appease the FAA by first registering our drone and then implementing remote ID.